All right. Yeah, thank you for the organizers. Thank you, everybody, for being here. So this is joint work together with Sam Boise, Frank Nagel, who were with me at Harvard Business School. And now recently, Sam is at the Linux Foundation, Frank is at MIT, and Kevin Chu, who is a co-author from GitHub and has always been there. So we're going to talk about the generative AI gender puzzle. And yeah, I want to motivate us very briefly, very easy to motivate, right? We can see in the workforce that there is an unequal participation. Women are less likely to be full-time employed, earn lower wages, are underrepresented in leadership positions, entrepreneurship positions, and the like. And when we look at the OECD and the literature, we actually see that there are statements that are made, well, keys to sustainable growth and innovation is really closing gender gaps. And some of our literature, in terms of looking at prior analog technology, television in particular, shows that technology has a role to play in reducing gender gaps. And so AI is one of the potentially most transformative technologies. More recently, we can ask the question, right, does this technology exacerbate or reduce any existing gender gaps? And there is work, of course, there's work in this space, and for example, by Otis and his co-authors from Berkeley and HBS that show globally across a different number, like large number of samples, that women are adopting Gen AI less than men. And so what we are asking is, do women adopt it actually less because they expect the benefits to be lower, or what is it about? And we do this in the context of open source software, so software that is publicly available under some permissive license. We are looking at the weekly activity from 1 year, weekly activity from top open source software contributors. We exploit the discontinuity in GitHub's Copilot program, where some top developers receive access to generative AI, GitHub Copilot, and others do not. So this is basically an extension, if you want, of a prior study of generative AI and the nature of works that we have out there, where we look at task allocation. And here we are looking at task allocation by gender in particular, and we document a novel Gen AI gender puzzle. And to just take this, to give you the summary of it, is what we find is consistent with the literature that Gen AI adoption is lower for women than for men. But interestingly, when we are measuring the impact on coding, or what we like to call core work before, it is stronger for women and weaker for men. And then we dive a little bit into the mechanisms. So we know there are around a share of 27% of women in tech, and you can see basically there is across jobs there's a large heterogeneity. So in some jobs you even have lower shares, and some you have higher shares, right? But the interesting aspect is that open source software, open source, the terminology is actually coined by a woman. So this is Christine Peterson who made up this term. So you may think, well, this environment may be maybe an environment where we find a substantial amount of women to be active. Could be one prior. Well, literature tells us that there are around 5% of top open source software contributors that are women, so actually substantially less. So what we are going to do is we're going to look at GitHub's open source software platform, the largest in the world, and we're measuring basically everything on the coding tab as coding. So you're creating projects, you're pushing code to the platform, forking repos and the like. And we're then looking at GitHub's Copilot program, which at the time really was just very simple. You put in the function header of what you might want, well, and GitHub Copilot is doing the rest. That is the optimal scenario at the time when it was introduced. And so GitHub introduced this program where they ranked individuals, and so they ranked projects really. Individuals were on those projects, and then some individuals right below a certain cutoff would get access to GitHub Copilot for free, and others would not, and we exploit that in a regression discontinuity design. So as kind of, or well, maybe to show you, one of the potential assumptions here is, well, people cannot move from the right-hand side to the left-hand side and get access to GitHub Copilot for free. And one question that was asked before this was introduced is, how do I even know where I'm standing? And well, what people were saying, GitHub Copilot is available for free as of right now to verified students and popular open source software projects. What GitHub defines as popular is sadly not expressly stated. So it's actually extremely difficult to manipulate here. So we use open and proprietary data to look at coding, the share of coding in particular, Copilot usage intensity, the internal ranking that we've obtained from GitHub, as well as gender prediction. This is very preliminary work. So in the first instance, we just used an R package that is based on US Social Security administrative data to predict gender based on name. But we are working on multiple other methods to identify gender based on name. But so far what we have is a balanced maintainer weak sample. We started with around 330,000 individuals, a little bit less than half of it, for a little bit less than half we have gender information, and around 20% are classified as female. When we go to our final sample, that is substantially more narrow, to say something causally, right at the threshold. We actually find that's around 16%, which is our first result. Basically, when you compare that with the literature of the 5% of open source software contributors being women, we find around 16%, that at least nowadays the share seems to be a bit higher. So this is good news in one sense. We cross-validated our measure with self-reported gender. So we have on GitHub, you can state whether you're, you can state, do you want to use a certain pronoun, yes or no, which pronouns do you want to use? And we checked, and this looks quite consistent with our predictions. And yeah, now we're using a bunch more methods to identify gender. Now, in the pooled sample, what we find is, here you can see the ranking at 0. This is a threshold, and on the left hand, on the y-axis, you basically see Copilot adoption or Copilot usage, if you like, and well, on the y-axis, and on the right side here, you can think of that as a control group. So they are adopting and using generative AI. They're using GitHub Copilot's coding Gen AI, but that is basically due to free trial access. But when you move from the right to the left-hand side, you can see a substantial increase of their Copilot usage. And so now we are interested in, well, what is happening across gender here, right? So this may be a little bit, this is a substantial amount of information here, but it's basically all the time the same. It's different measures of adoption and usage, Copilot days, weekly, cumulatively, the intensity, and have you ever used Copilot? And the important aspect is at the top you can see, the ones on that just get access, they are more likely to, males here in this case, are more likely to adopt. Their adoption increases, and relative to the darker green, which is females, they are adopting as well, but not as much as the males that we identify. And so there is this blue bar, this difference in the female-male difference that really shows us basically females are adopting substantially less than males. And that's true across all of those dimensions. So that's really the key takeaway on the adoption side. Now, what happens when you receive access? Well, to your coding activity, what we like to call core work, well, we find for males, we see an increase in your coding activity, but then for females, that is substantially larger. Now, of course, that turns this picture from before around. Now we see the female-male difference is exactly the opposite. Thank you. So one question you may ask is, well, why is this happening, this whole pattern, right? Like we see lower adoption for women, but then they're engaging there substantially more when they have access to the tool. Maybe this is potentially that the benefits are higher for them. But so this is kind of the, this first, we document this puzzle, and then we try to better understand it. And we don't, I have to clarify, we don't have the full solution, or like, we can't present you with all of the mechanisms here, but if you have suggestions, that would be very helpful. So of course, we have our own thoughts a bit. So what are potential reasons for the differences? Well, maybe at least on the impact side, this is just mechanical. In our sample, maybe women are coding, their coding activity is lower than those for males, and so it's easier to increase their coding activity relative to males. And what we find is, well, when we take apart their activities, and you can see this here in the first and second column, males relative to females, prior to the introduction of even the ranking, their activity levels in terms of coding is very similar. When you then go after the introduction of the ranking, that's also very similar. Here, this is the blue dot and the orange dot, but you can see the substantial increase for females in this orange dot relative to the baseline. So it's basically the same story, like females respond, but they have the same, respond more, but they have the same baseline level relative to males. So it's not that they're just, this is some kind of mechanical difference. Now, well, maybe it's a skill difference. If you think about this literature, the Gen AI literature, largely we have documented, I think, that it's the low ability individuals that are benefiting the most. And we, in our paper, have documented that as well. So here in our prior work. So this is prior work where we've shown that based on a number of ability proxies, for example, how central are you to certain projects in terms of your coding activity? It's what we call maximum centrality. What are your the number of achievements, badges that you get on GitHub, as well as the followers or your tenure level on GitHub. Based on those, we can see when we classify them people as high ability, they are substantially more likely to engage in coding. But the lower ability individuals do this even more, right? So maybe ability is, gender is just a proxy for ability. Well, I'm not showing this here, but when we include this, all of those kind of proxies for ability, our coefficients on gender basically don't change at all. So we don't see that this ability story matters. And it also makes sense in terms of our identification. We are looking at top developers, really, and women, they are relative to men, are probably have the same skill levels to begin with. So we don't think it's skill levels. And another story that we are currently working on to understand a little bit more is, well, AI could be a potential mentor, and maybe this is also about non-promotable tasks. We have seen the presentations yesterday. I think it was about coaching, for example, and I think we're thinking a little bit about that in the same spirit. So we know from the literature, women have potentially weaker networks or different kind of networks in terms of the quality, or just different networks, and they're engaging in more non-promotable tasks. Now, in our prior work, everything that was in the issues tab, where you interact with others to solve problems, and you assign other people to engage in some work. We call that project management, and we looked at that, and we find that basically, when you have access to the Gen AI coding tool, you reduce your project management activity when you're male, but you do this even more when you are predicted to be female. And so we see, again, this gender difference for females relative to males. And for us, that's some suggestive evidence that you don't need humans as much anymore. You can do the task yourself with Gen AI, and AI can substitute you as a mentor. It also implies that project management may be gendered here. And I'm going to skip to this one. I think this is more interesting. I then used ChatGPT. Just simply, I threw in all of the tasks that people engaged in and ask, well, what's the perception that this is a female task? What's the perception that that's a non-promotable task? And what it did was it classified everything that was a coding task, like creating a project, push, commit, forking, classified that at the bottom. Everything that was project management classified that at the top right as more perceived to be female, more perceived to be non-promotable. So maybe there's something to be said that potentially GenAI can reduce non-promotable tasks, and you can alleviate some of those alleviate some of those constraints, but also can be or is used really as a mentor, and probably is used differentially for men versus women. So just to summarize, we study gender as a moderator in the context of an GenAI natural experiment. We find 16% of top developers are female. We find this surprising generative AI gender puzzle. Women are less likely to adopt. They're more likely to respond to GenAI, and the effects are not mechanical or ability-driven. Likely this is a story about mentors and non-promotable tasks. So we do think it has a role to play to narrow gender gaps and redistribute tasks for women to focus on their core work. Thank you. Mm-hmm. So we try to rule out selection with this idea, right, that you're very close to the cutoff, and so that individuals on the left versus right are very similar. So I think that's one answer that I have to it. But of course, what we cannot rule out that there are going to be certain compliers that are, like some people. This is basically we are estimating a local treatment effect, local in two ways. Local at the threshold, right? So if we move the threshold, maybe this is different, but also locally in a sense that compliers are responding. So we would certainly have to figure out a little bit more about what are the attributes of those compliers to say a little bit more. Yeah. Yeah, exactly. Oh. Yes, yes. Mm. Right. Yeah, it's very interesting. We have thought about it. We haven't figured out a good way to identify that yet, and that could matter certainly for the adoption stage, right? You may adopt it less, but actually, it's not visible whether you adopt it or not. So nobody can actually see it, and maybe that alleviates a little bit the identity threat story. But certainly, maybe running an experiment to understand, like giving information. Let's say, well, we are going to reveal this type of information versus not. This could be one way to get at that, and and we have a little bit less on the adoption story. So that's something to think about. Yes, thank you.
That's all I have time for.
Yeah, thank you.